All right, you guys got a chance to try this on your own. We're going to do it together here. So remember, when we have a system of equations and both equations start with y equals, we notice that if they're both equal to y, then we remind ourselves the substitution property of equality. Equals may be substituted for equals in any equation and will remain a true equation. What that means is I can take the x plus 2 and the negative 2x minus 4, set them equal to each other because they're both equal to y. So now that I've done that, I'm going to be able to solve this equation for x and determine the x coordinate of the solution, and then after that I will determine the y. So first thing I'm looking at here is I have variables on both sides of my equation. I can only have them on one side, so I got to get rid of one of them. This right-hand side one is a negative, so that's a really nice one to get rid of. How do I get rid of a negative 2x? Well, if I add 2x to both sides, that's the opposite. So that will cancel that out. The whole purpose is to try to cancel out the x term over on this right side, so I only have x term on the left side. So like I said, since these are opposites, they cancel. If I added those together, negative 2 plus 2, I would get a 0. Okay, so the only thing left over here is this negative 4. Notice that it is a negative 4 when I bring it down. Over on the left-hand side, we have x plus 2x. That gives us 3x. Okay, I still have my plus 2 equal sign on the line here. And like I said before, negative 4. Okay, so we finished the first step. Now I have what is considered a two-step equation. So I have two more steps to finish in order to get what my ultimate goal is, which is x equals and some number. So the first thing I'm going to do is I need to, again, I'm trying to isolate this x. I'm trying to do some steps so that all I get is x equals. Right now I have this 3 and then the plus 2, okay? I'm going to get rid of the constant term first, so that's the plus 2. Is the reason why it's called the constant term is because it does not have a variable, okay? So a constant term is just a non-variable term, okay? Just a number, all right? And in order to get rid of a plus 2, I'm going to subtract 2 on both sides. Again, using a line to separate my steps. I have done nothing with the 3x in this step, so I'm just bringing it down. Anytime you haven't done something with in a certain step, you're just going to bring that down, okay? These are opposites, like I said, they cancel. That was the whole purpose, right? I'm trying to get x isolated. We've got negative 4 minus 2. Check that in your calculator if you need to. That should be a negative 6. Last step, I need to get rid of this 3. How am I going to do that? Well, I need to divide because it's 3 times x originally. So the opposite, we're always doing opposites. The opposite of multiplying by 3 is dividing by 3. So I've got my division symbols here. 3 divided by 3 is 1x or just x. Remember, I could put a 1 here, but you usually don't see it. But that's where that comes from because 3 divided by 3 is 1. Negative 6 divided by 3 gives me a negative 2. Check that one in your calculator if you need to as well. So you should have gotten negative 2 for your x. Now, in order to find the y, I need to take one of the original equations and rewrite it. I'm going to take the first one because it's the easiest, I think. Okay. Then I'm going to take my negative 2 and I'm going to plug that in where I see x in my equation. So I'm rewriting this. Y equals, put my little parentheses pocket here, negative 2 plus 2. Okay, and this is only one operation here, negative 2 plus 2, which actually gives us 0 because they're opposites. So y is equal to 0 in this case. So you should have gotten for your solution, okay, that the solution is the point negative 2 comma 0, right? I'll see you in the next video.